Yeah, hello together. Yeah, last time we wanted to calculate the Gini coefficient for a given income distribution, which we had here, and then we said we had a tax rate system, and this tax rate system should look like this, that the first 20,000 euro of your income should be for free. Then we have a linear increase of the tax rate from initially 20% to 40%, from 20 to 60,000 euros. And after that, the tax rate should be constant at 40%. Having this and knowing that this, of course, is then a marginal tax rate, this means, of course, if you earn, for example, 40,000 euros, then you do not pay for every 40,000 euros 30% of taxes, but you have also your tax allowance of 20,000 euros and then starting linearly up to the marginal tax rate of 30%. And having this, we calculated then there's, of course, somebody who earns 15,000 euro doesn't pay any tax. Somebody who earns 45,000 euro has to pay 6,500 roughly of taxes, and then 75 we had 18,000 euros taxes, and somebody who earns 105,000 has to pay 30,000 euros. And then we assumed that we have a redistribution, and this meant that hopefully in a democracy, everything what we are paying um, for the government in taxes, that this is then redistributed to all of us. And this means we need then the total amount of taxes. This would be then the sum of all single taxes. Didn't I wrote this down on the other slide maybe? No. Then at first we have to add up this. This is total taxes, and this would be then, I think I have it in my Excel sheet here, total taxes would, no, total taxes at all, we at first had to calculate how much. Now you don't see it. Let's move this like this. That we at first have to calculate total taxes. The first class has to pay, of course, nothing. Then the second class with 3,000, 3 million roughly, for 5.4 million, 6 million. The last class, because there we have only 200. Well, maybe we should also write this once down. That we have this one. This and this one, and then let's cut this here. Or let's make a new one. So we have done our number. Oops. Number 1, 2, 3, and 4. And this was 500, no, 1,000, 500, 300, and 200. And taxes were 0, 6.5625, 6.5625, 18 and 13. And then we have here total taxes is then just 1,000 times 0 is 0. In this case, 3,281.25, 54, and 6,000. And then we have here total taxes of 14,681.25, and this is redistributed to all people, which means everybody obtains a redistribution of 14,681.25 divided by 2,000, since we have 2,000 inhabitants, and this is then 7 point, where do we have it, 340625. And then we have income after redistribution, and this would be then everybody gets back 7,340 euros, and so we have new incomes of 20, 34, 45, 78, 64, 34, and 82, 34. And now the question was, well, how do we go on with our new income distribution? And having this new income distribution here, we want now to calculate again the Gini coefficient. And hopefully you can help me by doing this. What do I have to do now? I have to open the chat. This table I gave you also in your Moodle course. So question is now, oops, we are here. What is Gini for the new income distribution after the redistribution? What do I have to do now? Yes, great. Yo. Yes. Yeah. So, okay. So then we need fi, and I will put it, I think, here. So let's then start again with 0, and the first one would be then 50%, 1000 divided by 2000, and this we have to fix. So this would be 50, and then we have to aggregate. Oh, sorry, then we have to take here the sum. Starting at 1000 and to be 5. Oops. And then which number should be here? Which number should we have here? We have, oops, in the second class 500 people, and then this number in this cell should be yes, great, and I hope that my formula is right. Yo. So then I can go down 75, 90, and 100, and of course this have to coincide with these numbers because the numbers in our classes didn't change. Okay, and now we need the numbers for the income distribution. What do we have to do then? Keep in mind that we have here income per person. So after taxes, one guy in the lowest class has now not an income of 15,000 but an income of 22,000 roughly. So the first question we have now to answer is, what is now the total income of the lowest class? What do I have then to calculate? Yes, definitely. So we take these 1000 here times 22,000, and then we obtain this times this, And this, of course, we have to do for every class. So going down. So this would be then income per class after taxes. Okay, the next step. Yep. Mhm. Yes. So if I sum up all these numbers, what number will appear here? So of course we can just put it in our calculator, but actually I guess that we directly know what number will appear there. If you look in the table. So these are all the incomes of the former incomes minus what they have to pay for taxes plus what they get after the redistribution. Yes, great. Because nothing vanishes in our society. So if we take the sum here, hopefully I'm right. Okay, here are we at the 80,000. And now we have to calculate GI, and this we are doing in the same way as the FIs. So we start at 0%. Let's take also percentage here. And then we have to take the sum of starting with the first class, fixing the number up to the first class. Oh, dollar signs vanished. And divided by total income. So this number comes from 22,000 divided by 81,000. Here we have to sum up these two numbers. They are both roughly 22,000, 23,000. So the next number should be then 56 or 59%. If you are doing calculations, then also keep also in mind that you roughly know what has to appear there. Okay, there we are twice as large, 56%. This is okay. And then we are also at our 100%. And then we want to calculate the Gini coefficient. Yep. So then we can take this one here, put it here, and I think you know that we also need this one here. Oops, a bit too far. You see me still. And since we already have calculated this here, we can just put always the formula from here and copy it right here. Let's click in M5 minus M4. Okay, this is the right one. And then, of course, if we again call this X and Y, we need the product of these two. This one times this one. And then the sum, oops, equals sum and the Gini coefficient is then. Can anybody help me? Yes, 1 minus 73%, and then we see that we have a Gini of let's reformat this because the Gini coefficient is always shown as a number. Number and 2 digits. Okay. Up. Okay. I have to put and save this format also here. And yeah, let's put this also in our table here. This will be then income per class would be then 22.3, 22.9. Roughly, here we had roughly 93 and 65. 93 and 65, and I only want to put Fi and Gi, and this was then 50, 75, 90, 100, and to be complete we have 28, 56, 80, 28, 56, 80%, 100%, and then of course G C is 1 minus the sum of Fi minus Fi minus 1 times Gi plus Gi minus 1 equals 0.27, and compared to GC, so this is after redistribution, and this is before redistribution. the income distribution became much more equal. And let's also put this in a diagram. So I copy just the whole table. Together with median. And we want to insert also here the redistributed and this would be then Fi and Ci. And so we see here our Euler-Lorentz curve, that the gray one is moved just to our 45-degree line of the equal distribution. So let's put this also on our sheet here. So then we have blue, Lorentz curve before, Texas, and the gray one Lorentz curve after Texas and redistribution. Okay. Have you tried it at home? Did you obtain some similar results? But well, you have seen that it is more, or it is just okay, great. Then I think it is not that hard if you just once or twice try the formalism, then you just apply the formulas. Okay, then there was one exercise left. Oops, what happens here always? No, ich will nichts angezeigt haben. Oh, why is it not vanishing? What's happening with my... No, it's gone. Okay, so then the last task we had, because we just applied our formula, and this formula that this is true we want to show. So we want to prove that the formula we have applied a minute before is actually true. And for this, let's start again. How was graphically the Gini coefficient defined? G and F, 1 and 1. This was our 45-degree line. And then suppose we have a distribution looking like this. Then we would have here F0, G0, F1. This would be G1, F2, G2. And of course we have, if we put this here, this would be also F1, since this is the 45-degree line, and this one would be also F2 on this. And what was the Gini? The Gini coefficient was this area. Oops. No. Is this area divided by, let's take another color, red. Total triangle, and this triangle is just half of the square with length 1, so this is just 1/2, so the Gini coefficient is just 2 times this area. Well, and now we have to calculate this area, and this is, yeah, a little bit complicated, since let's have a look at this middle area here. What kind of geometric figure is this? These two, of course, are triangles, but well, let's take another color. Let's take green. So what kind of area of geometric figure is this? Well, these two lines here, they of course do not have to be parallel, but this line and this line, they have to be parallel. And if you have, yes, no, it's not a parallelogram, because this one and this one do not have to be parallel. We have only two sides which are parallel. This one and this one. Let's say A and B. A and B are parallel, and let's take this C and D, but C and D do not have to be parallel. Yes, this is a trapezoid. Then we have a trapezoid. And do you remember from school what's the area of a trapezoid? Or just have a look at the internet. What is the area of a trapezoid? Jetzt fängt es doch an. Well, the area of a trapezoid is the sum of the two parallel sides divided by 2 times the height of our figure. So if we maybe draw it like this, A, B, and then this is H, and then the area is A plus B over 2 times H. And now we know that the height of this trapezoid is F2, F2 minus F1. And we know that the height of that A is just this point here, F1 minus G1. So what we have is that the height of our trapezoid is F2 minus F1. A is this here, so F1 minus G1. F1 minus G1, and B is G2, and this point here is F2, so we have F2 minus G2. And this we have to collect, and though we know that the area of this trapezoid is then 1/2 times A plus B, F2 minus G2 times F1 minus G1 times H. Times, oops, sorry, plus, of course, not times. F1 plus, so this is A, this is B, times H is F2 minus F1, and this is H. And then let's write this in another way. So this is 1/2 times F2 plus F1 minus, open the bracket, G2 plus G1 times H F2 minus F1. And now we calculate this bracket here. So once times this and once times this. So we obtain 1/2 is f2 plus f1 times f2 minus f1 minus g2 plus g1 times f2 minus f1. And what is this? Hopefully you know from school what is x plus y times x minus y equals these are the so-called binomial formulas. First, second, and this is the third one. Yes, x squared minus y squared. And then we can identify x and y with f2 and f1, and we obtain, of course, 1/2 times f2 squared minus f1 squared minus g1 plus g2 times f2 minus f1. And now for the genie, of course, we have to keep in mind that we have to collect all these trapezoids. Let's go just back here. Here, if we go in this, or let's take this up. Let's copy this one and put it here. Oops. Where shall I put it? Let's put it here. So all these trapezoids here, these we have to sum up. These are triangles, but so to speak, you can say that a triangle is just a degenerated trapezoid where one side has just length 0. So taking the summation now means that for GC we have to sum up all trapezoids and multiplying by 2, so we obtain GC is then 2 times 1/2, and now the sum means that we have to start f2 plus f1, f3 plus f2, f4 plus f3, and so on. So we obtain fn squared minus fn minus 1 squared plus fn minus 1 squared minus fn minus 2 squared plus and so on. And the last one is then f0 squared plus the sum, and then we need this one here. No, sorry, minus. the sum of I equals 0 up to n, and then just fi, sorry, 1, I minus fi minus 1 times gi plus gi minus 1. So this will be this here, and this, if we have, since we have to take the sum, will be this. But what is this one here? If I calculate f4 squared minus f3 squared plus f3 squared minus f2 squared plus f2 squared minus f1 squared and so on. What do we see here? We see here that this and this cancels. This and the next one would cancel. So we then only left with the last value of f and the first value of f. And what is the last value of f in the definition of the Gini coefficient? What is fn? If you look at this diagram, so this is f0, f1, f2, and then we end up at what is the last data point in our diagram? 1. Great. So this is just this one here. So this fn squared is 1 and f0 is, we start where in our diagram? So then fn squared is 1 and f0 squared is, of course, where do we start? Here is our starting point. Oh, well, we start in the origin. And the origin is 0, of course. So, since everything here in the middle just cancels out, and this value is 0, we are just left here in the beginning with a 1, and these two and these two also cancels, and we obtain 1 minus sum I equals 1 to n fi minus fi minus 1 times gi minus gi minus 1, and here we are at our first formula. And then we should also show the equivalence between, oh, this you don't see, now you see it, the equivalence between this formula and this formula. So let's go here again. Oop. So what we want to show now is this equality sign. And there, of course, then let's put this one up to here. Then we have 2 is just the sum of these two sums. I have to show that 2 equals sum fi minus fi minus plus fi minus 1 times gi minus gi minus 1 plus the sum of fi minus fi minus 1 times gi plus gi plus 1. Do you have any idea how you can show this? Actually, let's just start by multiplying these two brackets here. And since we have a sum here, then we also can move out the summation in front of all. So what we obtain is sum over figi plus fi minus 1 gi plus fi minus fi gi minus 1, and the last one minus fi minus 1 gi minus 1 plus the second sum fi gi minus fi minus 1 gi plus fi gi plus 1 and minus fi minus 1 gi minus 1. And what you see now, well, if you take a close look, let's take some colors here, then this one and this one is the same. So, and what we see here is we have here a plus and this one, and the same we have here a minus and this one. So this and this cancels. What else? We have here a minus I minus 1, and we have here a plus I minus, there should be a minus sign. So these two also cancels. Cancel, cancel, and what is then left is I minus 1, I minus 1. So in total we obtain that we have the sum of 2 fi gi minus 2 fi minus 1 gi minus 1, the sum of course from I to n. And why is this complicated sum also just equal to 2? What again happens? Well, you always have to know what does this summation sign here means. And for this are these exercises that you learn how to calculate with these summation signs, because you quite often have these signs when you are doing statistics. Well, let's start from above again, from n. Then, of course, the 2 we can take out. Then we have 2 times fn gn minus fn minus 1 gn minus 1. Then we go one step back, so from n to n minus 1, so plus fn minus 1 gn minus 1. Oops. This one. Minus fn minus 2 gn minus 2 plus fn minus 2 gn minus 2 minus fn minus 3 gn minus 3, and so on and so on, and in the end again minus f0 g0. And again this one and this one cancels. This one and this one cancels, and so on. And we are left with f0 g0, and f0 g0 is again, so my chat also vanished. There it is. What is f0 g0? Oh, you can't hear me. Yeah. So sorry. Now you can hear me again, or? So you have seen that here again all these inner products that they just vanished, and we are left only with fngn and f0 g0. But this is and this is what kind of numbers? Again, we have the last data points at our Lorentz curve. So here we have 1, 1, and this is G0 and F0. So again, if we start in the origin, then this product is just Hmm? This one here. This is just the data point of the origin. And then it has to be 0, of course. And this is our endpoint. And this is then 1, of course. And then we end up with 2 times 1 minus 0 equals 2. Quod erat demonstrandum. Okay, so we are done with these exercises, and yeah, let's just have a quick start with our next topic, because then we want to start with linear regression. So, what happens today here? So, yep. Yeah. Did I? Okay. Did I forgot anything again? Exercise. So here, what did I forgot? Can you repeat it, please? Oh, the tile index. Okay, yeah. Oh, sorry. I can't forgot it. Yes. Then, since I do not have it directly, I just go in this one, and here we should find the tile index. So where is our tile index? This was the Herfindahl index, and there we are. Then let's cut this one, and we also go back in our exercise. Wait a minute. Yeah. And we need so my computer takes some time. And exercises here. And what we want to do is the tile index was this one. And now let's take this one here. So what we then need is that we, of course, at first, or if you have done it as a homework, maybe you can help us. What do we have to do? And we take maybe best just the data from here, and I think these data we need. So what do we have to do? Yes, great. Yes, great. So we need this one. This is mu is 40.5. Great. And then, yes, great. 40.5 and so on. I think everybody knows this, what we have to do. Then I will do it in a minute in Excel. And then, yes, great. Xi over mu. So we take here then ln of 15 over 40.5, doing also this, and then then I can say this is A and this is B. So we put here A times B. This would be then 15 over 45 times ln 15 over 40.5, and then yes, sum of all this, and the last step. Yes, great. So yeah, so please do not only divide this by 4, the number of classes, but then you have to divide this number by 2000. Great. And then we will do this also here. The tile index we need. So, oops, yeah. So first of all, here this was xi over mu. So this one is this divided by, and then I have to multiply it with 1000. Test. Yeah, okay, because the test worked. Okay, sorry, do not have to divide this by 1,000 because we have here the aggregated income. So sorry. Um, and then we have to multiply this. A and B is this times this, and the sum is summation, and then the tile index would be this divided by 2,000. Okay. Did you obtain the same value? No? Okay. So maybe it's also my calculations. Let's have a look if my numbers are here right. So this divided by 40.5, this is okay. And this also, and this is also okay. The ln is okay, and this is also okay. So my summation should be correct. So yeah, sometimes it happens. You have seen it. It happens also when I'm doing the calculations, and for this it is always quite important that if you are using your software package, that you always also know what you are doing, so that you have an idea where should I end up again. And this is then yeah, very important to make no mistakes and to correct yourself. Okay, then let's take this also here and copy. Let me have it here. Okay, but now hopefully we are done with the exercise. And I have not forgotten any other exercise. Okay? Because then we will start on Wednesday with the linear regression. They have asked you before, you haven't seen until now the linear regression, or in your introductory courses in statistics. Although I think, and then I will show it you. Okay. Then I stop.